Yeah, yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, right?
Yes, you're clear.
Fine, thank you. In the last class, I was discussing right HADOOP ecosystem components. Map reduce for processing, big, high. Okay. 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 So these are the HADOOP ecosystem components I'll be discussing, right? For storage, we have got HDFS. For processing, we've got MapReduce, Pig, Hive, and Spark argument for processing. One NoSQL database I'll be discussing. Some streaming technologies like Flume, Kafka I'll be discussing. Yes. Okay. A post is given, right? In that you can see the demo links, course demo videos, course content link, everything you can see that, and the payment process and the procedure, everything available in this short panel, right? Yes. So how exactly data stored and processed in Hadoop, right? In Hadoop, data is stored in the form of files. Each file again subdivided into blocks. Default block size 128 MB. In previous version, it was 64 MB, right? Design principles with respect to HDFS blocks. Every file will have dedicated number of blocks. Every file will have dedicated number of blocks. Every file will have dedicated, and in a single block, no two files data to be stored. For example, file 1 has got some 5 blocks. File 2 will have its own blocks. But in a single block, no two files data to be stored. Okay. How exactly data stored and processed, right? In today's class, like data storage and processing, how data storage and processing is going to happen. Okay, 4 cases I'm going to discuss here to make you understand how exactly data stored and processed. To make you understand, I'm going to discuss 4 cases here. Observe these 4 cases now. So totally you'll understand how the data is going to be distributed and how the data is going to be processed. Okay. So there are some couple of queries from the students, right? This is Spark by default implemented by using SCALA. Spark default built by using SCALA language, right? SCALA is the native language of Spark. Means SCALA is the language which is used only for Spark environment. No other environment using SCALA, right? So Spark by default built by using SCALA, and even we are using SCALA. Spark supports multi-language support. Spark has got, right? Not only Spark, it supports Python, it supports SCALA, Java, or language. 4 languages it supports, right? So mostly used ones are SCALA and Python. These days, Python also preferred. Previously, only SCALA was used. Now even Python is used a lot. Okay, so even so I'll be handling some PySpark batches also in the weekends. Spark with Python implementation, PySpark batches will so there, weekend sessions. Okay, fine. See, data storage and processing, case one. Observe this case one, right? Yes. Mm. So in Hadoop, data is divided into smaller parts. We call them as blocks. Number of blocks, for example, if the number of blocks, the file divided into n number of blocks, if the number of blocks greater than, or number of blocks, if it is equal to number of slaves, assume the blocks are slaves, more parallelism you see, more parallelism we observe, right? Yes, more parallel, high speed you see. So for your understanding, I'm taking, okay, think that there are 4 blocks, think there are, okay, 4 slaves available, otherwise 3 blocks, 3 slaves, blocks b1, b2, b3, slaves, assume that slaves are slave 1, slave 2, slave 3, 3 slave systems, 3 systems assume. Okay. So here, if I'm taking a file f1.txt, yes, f1.txt, file 1.txt, the size, assume it's 192 MB. Default block size equal to 64 MB. Number of blocks, how many? 192 by 64. 192 MB file divided into fixed size chunks called blocks, like 64, 64. Each block of size 64, right? So how many blocks you will get? 3 blocks exactly, right? And see that B1, B2, and B3. B1, B2, and B3. Assume you have got some 30 lakh records. Okay. In B1, 10 lakh assume. In B2, 10 lakh assume. In B3, 10 lakh records assume. How this data is going to be stored within? This is the master. These are the slaves. These are the master. These are the slaves. So here, slave 1, slave 2, slave 3. So within this, we have got some processes running within the slaves called like data nodes. And within this master node, we have got a name node available. What name node does? Stores metadata. Name node stores metadata. Metadata means data about data. It won't store, name node or this master node won't store the actual data. It stores data about data. Okay, here data node stores the data. Slave nodes are, this data node stores the data. Data nodes, this slave nodes only going to store the data. They are only going to process the data. So here B1, B2, and B3. B1, B2, and B3, right? Yes. B1 has got 10 lakh, B2 has got some 10 lakh, B3 has got some 10 lakh. Means, okay, here your data is distributed across multiple slaves and the data is processed by multiple slaves parallelly. So here, if you see in this master node or this name node, your file f1.txt divided into how many blocks? B1, B2, and B3. Your file divided into 3 blocks, where B1 is stored in slave 1, where B2 in slave 2, B3 in slave 3. In three different blocks of a single file stored in 3 different slaves. and are processed parallelly. Execute. Okay, now this is what how the data is getting stored. If you take a file, how it is stored, how it is divided into blocks, into how many blocks, what is the fixed size, what is the size of the blocks, and how they are distributed across layers. Now, if you talk about this data processing, for example, for example, your job is to process f1.txt file. So in Hadoop, always job divides into tasks, number of tasks. If you want to parallel processing, means compulsory your job need to be divided into tasks. For example, if I take a labor example, so if you got some 10 labors for constructional work, for doing a job, construction job, a building construction, means if your job is divided into multiple tasks, you need to divide into 10 tasks and give to 10 labors. They will be parallelly working on it and finish that job. Means if it is not divided into tasks, means you can assign the job to only one person. Only one person will be working on the entire job, which is time taking. If you divide it into multiple tasks, and if you are distributed across multiple labors, they are going to run. For example, a job takes 10 hours to complete, where it has got 10 parts. Divide the 10 parts, and the 10 parts give to 10 people. They'll be working parallel, complete in 1 hour, right? If single person taking 10 hours, in the same way here your job divided into tasks are distributed across multiple slaves and are processed parallelly, right? So number of tasks in Hadoop always depends on number of unique blocks. I'm using the word unique. I'll say why. Later I'll discuss why we are using the word unique when we go for replications. Okay. Number of tasks depends on number of unique blocks. How many blocks here? 3 blocks, right? 3 blocks means 3 tasks. Which are the 3 tasks? T1, T2, and T3. Observe 3 tasks. So here processing the file f1.txt, which is stored across multiple slaves, which is divided into multiple blocks stored across multiple slaves. So your job divided into task T1 task, T2 task, and T3 task. T1 task is for what purpose? For executing B1 10 lakh records. T2 task for executing for what? B2 block 10 lakh records. T3 task is for what? B3 10 lakh records. Who should execute this T1 task? Who has to execute this T1 task? Which system or slave need to execute? Yes. Which system or slave has to execute this? T1 task is for executing B1, right? Means B1 present in slave 1, right? Means slave 1 or system 1 only need to execute, right? There is no other choice. Can S2 execute this B1 block? S2, can it execute B1? No, right? No. For example, if I give a labor example, if I talk about labor, so for example, there are 3 students, student 1, student 2, student 3. Student 1 is from mathematical background. A student 2 is maths, he is good at physics. Student 3 is good at chemistry. If any task related to physics comes, I need to assign to student 2. No other choice, because the other students doesn't know physics. If any task related to chemistry, I need to assign to S3 only, no other choice. If any task related to mathematics, you need to assign to student 1. So depending upon the task, which means here B1 block need to be assigned to, B1 block should be executed by S1 only, no other choice. Because B1 10 lakh records present in the system 1, the system 1 can only execute. So system 1, slave 1. B2 by S2, no other choice. B3 by S3 only. So the master or name node can select only this. Is the task divided on the basis of slaves? No. No. Is the tasks divided on the basis of slaves? No. Number of tasks in Hadoop always depends on number of blocks. If 10 blocks, 10 tasks. If three blocks here, right? Your file divided into 3 blocks. That's why 3 tasks. If your file has a bigger file, some 20 blocks, 20 tasks you will be using. 20 tasks will be distributed across these 3 slaves. 776 means some tasks will be in the waiting state. Nearly 6 tasks will be in the waiting state. Okay, but in our example, blocks are 3, slaves are 3. So here B1 T1 task assigned to slave 1, T2 to S2, T3 by S3. So T1 task assigned to slave 1 to execute B1 10 lakh, T2 task assigned to S2, T3 to S3. So here all the 3 tasks T1, T2, T3 are executed by 3 slaves S1, S2, S3, right? All the 3 tasks T1, T2, T3 are executed by 3 slaves S1, S2, S3 parallelly. All the 3 tasks T1, T2, T3 are executed by the 3 slaves S1, S2, S3 parallelly, right? Yes.
I
So
have a question here.
yeah, one second. All the 3 tasks are executed by the 3 slaves parallelly. So no tasks are in the waiting state, right? No tasks are in the waiting state. So full parallel processing, full parallelism is in. So we see high speed here, right? Yes. Yes, go with your query, right?
Yeah, thank you so much. So, so you got me you mentioning about the job, right?
Hmm.
And then relevant task, right?
Hmm.
For that one. So, how it differs from a job, one job to another job, and one task to another task? Let me put it in a simpler way. So, what is the basic difference between a job and task?
So okay, for example, I'll make you clear with a labor example, right? For example, if I take any college environment, there is a placement drive in the college. That is the job. Job is what? Conducting the placement drive. The college need to conduct it. So generally, who takes that responsibility? Principal. That is not principal. What he does? Principal. What he does? Principal is like okay. For example, this master node. Principal will be like master. He won't execute anything. He won't take the risk. What he will do? He will divide that job into multiple tasks, and he will allocate 3 persons for that. He divides the job into 3 tasks, and he'll allocate for executing the 3 tasks. He is allocating 3 persons. Here also same. The job divided into 3 tasks T1, T2, T3, and the 3 tasks assigned to the 3 slaves. Which slaves depends upon, right, where that data is stored. You will provide data to that. For example, 3 faculties you are providing for, as you are assigning, right? First faculty you will assign some data and you will give some tasks. Second also you will assign some data, and third also you will assign some data and resources, and you will give the tasks. Means your job is to that entire thing. Here also job is to process the entire thing. And where, see here, task is executing this 10 lakh records is your task 1. Executing this T2 10 lakh records is task 2. If all these records are executed, means 30 lakh records are executed, means your job is completed. Means this 30 lakh records, if executed by a single slave system or a single person, as we say, right, takes time. So you are distributing across multiple slaves and are making it to process it parallelly, right? So job is to process something, and that you will divide it into multiple tasks. You may ask why you will divide into tasks. Means if you are dividing into tasks only, you can see parallel processing. Otherwise, there won't be any parallel processing. Only one person, only one slave only need to execute the entire job, which is time taking, right? Yes.
Got it. Thank you.
Okay. But here, okay, this is case one. What I was discussing is case one. If the blocks are, but observe this case two now. Observe this case two. Number of blocks means if your file divided into blocks, number of blocks greater than number of slave systems. Number of blocks greater than number of slaves. Less speed you see, you'll see less speed. Think you got 4 blocks. Think that you got 2 slaves. B1, B2, B3 and B4. 2 slaves, S1, comma S2. Okay. B2, B1, B2, B3, B4. Okay, S1, S2. Now, if I take an example, f1.txt, assume the size is like 230 MB. Number of blocks, the file is divided into how many blocks, means 230 by default block size, whether it is 68, 128 or 64, whatever it is, assume it is 64. That means it is divided into 4 blocks. B1, B2, B3 and B4. These 4 blocks stored across this, so within this cluster, I got only 2 slaves available. Assume you got less number of systems or slaves. Name node, this we got data nodes. B1 here, B2 here, B3 here, B4, whatever it is, 2 blocks in slave 1, 2 blocks in slave 2. So here your job, there is name node stores metadata, right? Data about data. So the file f1.txt. So tomorrow, if you want to retrieve the file, this master node should have the knowledge about the file is stored in which blocks, the file is divided into how many blocks, and in which slaves that the blocks are stored. That information should be available. Then only it can combine or it can retrieve, right? Yes. B1, B2, B3, B4. B1 by slave 1, B2 stored by whom? Slave 2. I want the sessions to be interactive, right? Keep responding. B3 in which one? Slave 1. B4?
Slave 2.
So 2 blocks in slave 1, 2 blocks, in slave 2, 2 blocks. So that is how the data distributed, right? If you got 40 blocks, only 2 slaves, 20 blocks in slave 1, 20 blocks in slave 2. For example, data processing, if you observe this data processing. So generally, yesterday also some query was asked, why I need to switch to big data Hadoop or Spark? Why? What advantage means? The motivation towards Hadoop or Spark. What motivates you means one thing. See, if any task is given, what are these databases? See, you have said it's from database side to why we need to go means ST itself. Be in the previous classes, I have given example, right? It's taking days of time. Specialized databases are there, right? Which is taking hours of time. But where Hadoop is taking minutes of time. Hadoop is taking minutes of time. But one thing, right? Spark. We are discussing Hadoop and Spark, right? Spark is 100 times faster than Hadoop. Spark is 100 times faster than Hadoop. Okay. Means previously Hadoop processing is used, but now Spark processing. See, if you talk, I was giving in the first initial class, Hadoop is meant for storage and processing. Processing previously MapReduce was mostly used. Now Spark is used because Spark has got very high speed as compared to other technologies in the market. It's very high speed processing by Spark, used for batch processing, huge data in a very quick time. The events generating at what speed? In the same speed Spark can process. The rate of speed of the events the same way. Okay, so coming back to our discussion, right? So this was a data processing, right? So here, number of blocks and number of slaves. Okay. So here 4 blocks are there, 2 slaves are there, right? 4 blocks stored across 2 slaves. Okay, now data processing, right? Job to process f1.txt, job divided into tasks, number of tasks. Always depends on number of unique blocks. See one thing, once again I'm saying Hadoop is meant for batch processing. Millions and trillions of records you are going to process it. The data you are bringing from different data sources or data bases, and you are going to dump into this HDFS, Hadoop HDFS. Number of tasks equal to number of unique blocks. How many unique blocks here? Yes, try to answer. How many blocks here?
2 blocks.
4 blocks.
4
P1, B2,
blocks.
B3. 4 blocks, right? 4 blocks means executing 4 blocks we require 4 tasks, right? T1, T2, T3, T4. Okay. Four tasks. Four tasks. Why? Because number of tasks equal to number of unique blocks. How many blocks? Four blocks. Four blocks means four tasks. Means job to process f1 dot txt. f1 dot txt. Okay. T1, T2, T3, and T4. T1 is for executing. T1 is for executing what? B1. T2 is for executing B2. T3 for executing B3. T4 for executing B4. Now try to say T1 who should execute? Yes. Okay. Who should execute T1 task? Yes. Slave 1 only should execute, right? Yes. T1 task is for executing B1. B1 is present in slave 1. So slave 1 only execute. Who should execute T2 task? Who should execute T2 task? Yes, 2. T3 task. T3 task who should execute? Yes. You can unmute yourself and you can give your response through voice, right? Anyone, right? T3 by S1 again. T4 by S2 again.
So, sir, each slave have only two processes, or it is more than two also possible?
Which one you're talking?
Just now you have give example that task distribution, right?
Mm.
So
So
S1,
here,
S2, S1, S2.
yes, S1, S2, S1, S2 means here two systems only available.
Okay,
Two systems only available. So two systems only available means the blocks can be four blocks available means four systems available means four blocks in four slaves. But four slaves not available means what you will do? Two blocks in one, two blocks in one. So here I'm going to say the same thing, right? So here T1 task and T3 task by slave 1, T2 and T4 by slave 2. So here observe carefully. Slave 1 is the slave 2 is the slave 1 executing T1 and T3, S2 executing T2 and T4. Observe carefully when T1 is executing, T3 will be in the waiting state, right? When T2 is executing, T4 will be in the waiting state, right? How many tasks are executed parallelly here? How many tasks are executed parallelly here? Out of four tasks,
two.
only two. Remaining two are in the waiting state, right? Until you complete these two tasks, you cannot execute the other T3 and T4, right? Means
Correct, sir.
here some tasks are in the waiting state. Some tasks are in the waiting state. So here less speed you are going to see. For example, if I give a labor example, there are four tasks. Only two labors are available to do that work. Labor 1, you need to assign 2 tasks T1 and T2. And for labor 2, you should assign T3 and T4. 4 tasks, each task 4 tasks, each task 1 hour. Each task 1 hour. So to execute this 4 tasks means 1 job. To execute the job, how many hours required? Now here. Total number of hours. 2 hours, right? So first T1 and T3 executes parallelly. Next T2 and T4. Once T1, T3 execution finished, next T2, T4 will be executed. 2 hours time it takes. But in the previous case 1, if you see, 4 tasks are given to the 4 slaves. How many? How much time? 1 hour only, right? 1 hour only, right? In the previous case 1, 4 tasks, 4 slaves.
Yeah, 1 hour.
All the 4 tasks are executed by the 4 slaves parallelly. Takes 1 hour only. Here it taking 2 hours. But here that's why I'm saying less speed, time taking more. So here some tasks will be in the waiting state. Okay, now observe this case 3 now. Case 3, if more blocks are there, more blocks, but only one slave is available. For example, B1, B2, B3, B4, 4 blocks, only one slave, S1. Think this is the master, these are the slaves. Only one slave only, right? S1. So B1 stored here itself, B2 stored here, B3 stored here, B4 stored here. Here f1.txt, it is divided into 4 blocks, B1, B2, B3, B4. B1 stored where? In slave 1 only, B2 in slave 1 only, B3 slave 1, B4 also in slave 1. Okay, B1, B2, B3, B4, S1, S1. Okay, now observe that. Now here, your job is to process f1.txt. 4 blocks means 4 tasks. 4 tasks T1, T2, T3, T4. T1 is for executing B1, T2 for B2, T3 for executing B3, T4 by B4. Who should execute this T1 task? Slave 1. T2,
S1.
S1, T3, S1, T4, S1. All 4
4
tasks,
hours.
T1, T2, T3, T4 are executed by slave 1 only, by S1 only, sequentially. If each task taking 1 hour, total time taken
4 hours.
4 hours. In case 2, 2 hours.
2,
2
3,
will be
4.
running. In case 2, it will be 2 hours. In case 2 will be running, 2 will be in the waiting, right? In case 1, only 1 hour it takes. So what is your observation? More slaves, more parallel process, more speed. If less slaves, less speed. If only one slave, no parallel processing at all, it takes one sequential execution, right? Yes. So here you might get one query here. So as these are machines, slaves are nothing but machines, right? Go back to this case 1. Yes. As this slave 1, slave 2, slave 3 means what? Systems. System 1, system 2, system 3. As these are machines, when 3 tasks are executed by 3 slaves parallelly, suddenly if this particular slave is down, slave 2 is down, suddenly slave 2 is down, means 2 drawbacks you observe here. 10 lakh records or 10 lakh records are lost. B2 block is lost. 10 lakh records are lost. Is that is one. T2 task will be failed. When T2 task is failed, job also will be failed. Right? So two things, storage wise, processing wise. Storage wise, 10 lakh records are lost, and processing wise, T2 task is failed, job also gets failed. Here 10 lakh records lost means it's a huge loss, right? If it is sensitive data like banking data, if it is insensitive data like any social media or Facebook data, it's okay. But if it is insensitive data like banking data, right? Huge data lost, 10 lakh records lost. How Hadoop is able to overcome these kind of situations means there's a concept called replication and fault tolerance in Hadoop. Using that replication and fault tolerance, we are going to solve it. There won't be any data loss. There won't be any task failure. The job won't be failed. So how that fault tolerance is implemented in Hadoop and how the replications are implemented in Hadoop, we'll discuss in tomorrow's session, right? So today just I was discussing these three cases. What happens if the slaves are less, if the slaves are more, if there is only one slave, right? And how the data, how this data and storage, that is storage and processing is going to happen, right? Tomorrow my discussion will be on fault tolerance, how this fault tolerance is implemented in Hadoop, and replications means duplications, and how this kind of situation is overcome in Hadoop, right? Data loss or task failure, right? Fine. I'll stop today and we'll continue tomorrow, right? More discussion on this. Fine. Any queries you got? So after this completion, right? First, I don't know like how many of you got basic Linux. So I'll be discussing the basic Linux commands before I go with the Hadoop commands, HDFS commands, right? So I'll be just basic Linux commands knowledge is enough to work with this HDFS or Hadoop commands. Before that, I'll be also demonstrating about the software, right? How to download and how to work with it, how to use it. I'll be forwarding to your Google Drives the software. Notes you will be getting to your Gmails, right? Yes, and videos you will be getting to Google Drive. You can just check that the drives, the videos of yesterday's and day before yesterday, right? The videos link is provided in the chart panel, and the course content link is given, right? Yes. So I'm stopping for now. Meet you tomorrow, same time with the same link, right? Tomorrow also you can attend the session with the same timing and using the same link, right? Yes. And day after tomorrow, the link is going to change, right? Tomorrow you can attend, but day after tomorrow, the link will be changing. Fine. Okay. So you need to get registered. You need to get enrolled, right? So I said a WhatsApp group also going to get created. Fine. So I'm stopping for now. Meet you tomorrow, same time. Let's use the same link. Thank you all for your time. Thank you.